All right, this first one was pretty nice because they gave us two pairs of angles already congruent, and it wasn't a bow tie, but it did have a pair of shared sides. And when the triangles share a side, we can say that LK is congruent to LK using the reflexive property. And that gave us one set of congruent sides. And if we look at just one triangle at a time, we've got an angle here and an angle here, and the side that's between those angles is marked congruent. So that's the formation that tells us the triangles are congruent by angle, side, angle congruence postulate. On number 2, we started out with a pair of angles that was given congruent and a pair of sides that were congruent. And this was shaped like a bow tie, so hopefully you marked that those angle S's in the middle were congruent to each other, because they're vertical angles. Just because I have it ASA on my proof doesn't mean it's ASA on the triangle. We better check the picture. You'll notice that we have an angle and we have an angle, but the side is not the one that's between those two angles. The side that's marked congruent is only next to one of the angles. So I'm going to call that angle side congruence theorem. Number 3, I'm given perpendicular, and theorem 3.9 says if you have perpendicular, then you have 4 right angles. And so the statement that goes with that one is that I have these right angles sitting right here. I was also given a pair of congruent sides, and this doesn't look like a bow tie, but do you see that they're sharing a side? And so I can say that side XZ on one of the triangles is congruent to XZ on the other triangle. By the reflexive property. This is not a side-side angle. What is going on here is one of our special ones where there's a right angle, and we were given that the hypotenuses were congruent, and we showed that we had a leg that was congruent on each triangle, so this was triangles congruent by the hypotenuse leg congruence theorem.